Hello everyone, welcome to lesson 8, extracting geometry, locations, points and curves. So far we've worked with parameters, types and sheets. Now it's time to explore geometry. We've learned how to extract location points, curves and line geometry from elements like walls, ducts or model lines. Understanding element geometry is essential for tasks like clash detection, placement and measurement. Many components have a location point which returns an XYZ object. This is useful for tagging, moving, or analyzing locations. Now let's get the XYZ point of a place family instance like furniture. I'm going to search for Python script node and edit it. First of all, as always, we import common language runtime and we load the required .NET assemblies. First of all, Revit services, and then Revit API. Now let's import classes from Revit services dot persistence we import document manager, and then from Autodesk dot Revit dot database we import all. Now we choose the current session of Revit by saying document manager dot instance dot current database document. Now we need to set our first input. I'm going to name it input underscore data, and of course we need to unwrap it because we are importing it from Revit. And this is our input. Now we want to ensure that the input is always treated as a list, even if it is a single element for consistent processing. I'm going to create a variable and name it elements. And by saying our input data if is instance, and as an argument we need our input data, and as a second argument list. Otherwise, make me a list of my input. And now, because we are going to list XYZ points, we need an empty list. So we are going to name it output, and let's make an empty list. To get the location, we are going to iterate through all input elements. For that, we are going to use for loop. We are going to say for L in elements. I'm going to use conditional if L is none. We are skipping the non-element. Output dot append a phrase saying element is none. And then continue. And we say try this. I'm going to make a variable, name it loc for location, and we are going to get the location of our element. And then we use an except. And we say in output append let's say element has no location property. By these lines, basically we are skipping the objects that they don't have actually location based point. And we say continue. If the location is a point based location, the script extracts the XYZ coordinates and appends them to the output list. We try another conditional format by saying if in instance our variable loc and its argument location point and as a variable for point I name it pt loc dot point, and as an output we append in our list actually a list of XYZ points. And we say otherwise in the output list append a phrase saying element has no location point. We get out of our conditions, and as an output, we need our variable named output. We need to provide our input data. So I'm going to choose a family, this one, and I'm going to search for categories node, and since it's a furniture, I'm going to search for furniture and all elements of that category. All right. Then we need to filter that family, right? So I'm going to search for a string from object. We convert our elements to a string, as you can see. And to filter that, I'm going to search for a string that contains. We are looking for a specific family, this one, and this node will give us a list of true and false. And at this point, I'm going to search for filter by Boolean mask. As a list, I'm going to provide it our main list of elements and the Boolean node as a mask. And here we end up with two lists of our family that we were looking for, and the other ones in another list. So we need our input to wire it to our first input of Python node, and let's run. So as you can see, basically we extract our list of the locations of each family that we provide to Python script. For the second part, I'm going to get location curve, extract the line or curve of a linear element like a wall or duct. In this example, our element would be a wall, and this is great for extracting geometry of linear elements, useful for coordination, dimensions, or even exporting to CAD. Now let's copy our Python script here and edit it. I'm going to clear up to this line here. And I'm going to name my input as element. And of course, I need to unwrap it. By saying unwrap element between parentheses and our input. For the location, I'm going to get the location of an element. Dot location. And I'm going to use if conditional by saying if is in instance my element, actually location, and as an argument location curve. For the curve, return location dot curve, and we need to actually search for a start and end point. I'm going to create a variable, name it start, and from the curve we get end point as an argument 0, and I'm going to explain it in a minute. And curve dot get endpoint again 1. This 0 and 1 is related to how Revit's geometry API works, especially for curves. Actually, we are getting the first point or a start of a curve and second point or end of the curve. Now, as an output, we make a list by a string saying start, and return me the start point, and another string, and which will returns our end point. And we say otherwise in the output list say element has no location curve. We need to provide our input. I'm going to search for select model element, and let's select like this wall over here, and let's save and run. Here we retrieve our start and end point of the curve of that 3D element. For the final part of this session, we are going to convert curve to dynamo geometry by creating a dynamo line from the Revit curve. By converting Revit's geometry to dynamos, you can use it in downstream geometry operations such as offset, intersections, and annotations. So I'm going to copy this node here and use it again because the most part of it we need it. First of all, we need to add another reference which is protogeometry, because basically we are working with the geometry inside Dynamo, and then we need to import point and line. So we say from Autodesk dot design script dot geometry import point and line. This is our document. This is our input element, which is good to go. We need our location of that element as well, and our start end point of the curve of that element, and we don't need this lines here for now. And here we need to convert Revit XYZ to Dynamo point. So for that reason, I'm going to create two variables and name it start underscore point. And I'm going to create point dot by coordinates. It's the method to create nodes, and as an argument we need a start dot as a x. Of course this wasn't the one that I was looking for, as a variable x, and a start we retrieve y, and from a start point we take z, and for the end point the same. Point by coordinates, and let's copy this line and use it, and we change the start to end like this. Now we are going to create Dynamo line. I'm going to name it Dynamo underscore line, and this is the method that we create line by a start point end point, and as an argument we need these two variables that we have just created, and end point, and as an output we retrieve our Dynamo line. We can say over here otherwise, as an output give me a phrase, let's say element does not have a location curve. The output, let's select the same wall and let's run. As you can see, we retrieve the line of that wall as a curve inside Dynamo. In this lesson, you learned how to extract location points from family instances, get location curves from linear elements, and convert Revit geometry to Dynamo geometry. In Lesson 9, we will explore how to filter and find specific elements in your model using rules like parameter values, categories, and more.